Hello, my name's Luke and this is the second episode of the mini Porsche project. This video will be about the cylinder heads of the Porsche. As you can see, I already 3D printed a little model of it from the current CAD, and I will show you in detail how I designed this part. And in the end, I will also do a little simulation, or I can show you a little simulation of the rockers and the camshaft inside this housing. So stay tuned and I hope you have fun with it. Whoa, but wait a minute. While I was cutting this video, I realized it's going to be way too long. So what I will do instead is I will show you now only the CAD model and the 3D printed parts. And in a second episode, I will show you the simulation. Nevertheless, I wish you lots of fun with this video, so let's get back to it. So first of all, we will take a look at the CAD model of the cylinder head, and I will give you a little overview and some details about the design itself. So the attentive followers among you will recognize that some changes have been made to the geometry. For example, there is an intake manifold, even with a little airbox on the right corner. We have the cooling fan now in place with maybe a starter motor or at least an alternator. There are some chain belt housings for the right side, or for the right side of the cylinder head. And there are also some wheels and tires and a little wheel hub, brake discs, and you can see a prototype of a differential in here. So, but today we will focus on this particular part, as I already said, the cylinder head, and therefore we will open up the assembly. So if we take a look from the top, you can see that the assembly now contains the cylinder head itself, the mounting brackets for the rockers, two different sets of rockers for the intake and the outtake valves, as well as the valves themselves, and a pulley in the front for the camshaft here inside. I will just quickly hide the cylinder head so you can see it. There you have it. You can see the camshaft. When I create a section through the cylinder head, you can see how the parts are now divided up. So there on the left side would be the exhaust manifold. On the right side there would be the intake manifold. Therefore there are now two different sets of valves, a longer and a shorter version. By now I'm not sure whether I want to use the longer or the shorter. It depends on the screw, which will be screwed here on top into the thread, because with this screw you can set the play between the rocker and the valve. There should be a little bit of play, not too much, but a little bit, so that the valve always can close entirely, so no gases will escape during the compression process. Another thing you can see in the middle is the camshaft and the rockers on the left and the right side. Maybe we will stick for a moment to the rockers. The left rocker here has a quite simple design, nothing special about this, but as you can see, the right, it has to bend around the cam of the other rocker. And this happened because the mounting holes for the brackets are in the same line, but the cams on the camshaft are in different positions because the intake and the outtake cams have different timings, of course. Now therefore the rockers, or one of the rockers, has to make a curve so it won't be affected by the other cam. To be honest, it doesn't look that pretty, but I think it will sustain the force applied to it. And yeah, it does the job. One interesting thing here is when we look at the camshaft, of course it can only turn into one direction, which will result in two different sets of movements for the different cams. So here now the cam turns anti-clockwise, and therefore the right lever, the right rocker, will be pushed from the bottom to the top, and therefore will create a force on the valve which will go from the top to the bottom. But on the left hand side, it's the other way around. Cam can't push the lever from the bottom to the top because of the turning direction. This means the camshaft has to push over the lever from the top to the bottom and therefore create the same motion on the outside, which will also go from the top to the bottom. Because of this circumstance, I created a simulation which I will show you later on, because there will appear several issues. By the way, this is almost the same design as in the original cylinder head. Even the positioning is nearly the same. The positioning plays a very important role because the contact surface or the contact line between the cam and the lever always has to be, or at first has to be, above the vertical line of this axis, of the rotation axis of the lever, in order to create a moment which will push the lever around its turning axis. One issue which could occur is while the cam is pushing the lever, there could be too much force applied onto the bracket, and this little arm where the lever sits on could simply snap off. That's something I clearly want to avoid. That's also a part of the simulation, to check if the bracket can withstand the applied force due to the turning and the friction of the camshaft. So, but for now we will focus on the cylinder head itself. One thing which is worth mentioning is this hole here, which will go from the front almost to the back. And to this line, it's an oil feeding line. There are connected for each cylinder at least 3 holes which will apply oil on the one hand to the cams and on the other hand to the frictional contact between the cylinder head and the camshaft. So let's take a look at the cylinder head. So for the overall shape, I had to do a compromise. Normally in the original Carrera 3.2 liter engine, the cylinder head is made out of 4 different parts. If you take a look from above, at least along this line, the head would be split into 2 parts, which would be the cylinder heads, or the original cylinder heads, and 1 camshaft housing. And also this one block of a cylinder head would be divided up into 3 compartments, so each cylinder has its own head. Therefore, on top of the 3 heads there would sit this one combined camshaft which will top off the heads. Unfortunately, I wasn't able to recreate this design due to the different holes and especially the size of the holes. And one hole I want to consider here is the thread for the spark plug. If you compare a normal spark plug in a normal car to the size of the valves, the spark plug is magnificently smaller than the valves. I wanted to go with a standard glow or spark plug, and the smallest one I was able to get is, I think, a 1/4 inch thread spark plug. And this is why the thread compared to the valves it has almost the same size, as you can see. This results in a very interesting configuration. Normally the valves would not sit in the same line, they would be turned slightly, so the positioning of the cam would be a different one. Also, it was very difficult to get a specific angle for the spark plug, so neither the mounting holes nor the valves and channels for the valves would intersect the channel for the spark plug. Now, if we take a look from the side, you can see that behind the spark plug there is a pocket for a mounting screw, which means that when I have to assemble the engine, At first, the screws will be put in place which are behind the spark plug, which are those three on top. And later on I can set in the screws for the other areas. So now if we turn it slightly to the side, you can see that here are little pockets for the screwdriver, so I can easily screw in and screw out the screws. So the next thing I had to tackle is the oil circuit for the cylinder head. As I already mentioned, the feeding line is here on the front surface, and you can see it maybe from this angle. For each cylinder, three feeding holes are here to oil the cams and the rockers, and to oil the surface for the frictional contact of the cam. Of course, the oil has to go back then to the engine, and therefore there are those channels at the bottom and those holes here which will direct the oil back to the engine block. Which means, as in the original engine, there are two oil return lines which will be sealed up with rubber O-rings and some tubes which will feed the oil back to the engine. Let's go back to the assembly and I will show you how different parts are mounted to the cylinder head. Maybe we will start off with the camshaft. Therefore I'll just activate a section through the head. And what we can see here is that in the front and in the back there are two ball bearings which will guide the camshaft, and there are two frictional bearings in between which will provide extra stability so that the cam won't be pushed or bent during turning. Again, looking at the section, you can see how tight the spacing between the different cams and the lever is. So in the front, the camshaft gets driven by a little pulley, which will be driven by a pulley inside of the engine block. And already in the engine block integrated is a gear which will reduce the number of turns by half. One interesting detail to note is the angle of the spark plug or of the glow plug. You can see it's not only tilted a bit to the left, it's also tilted, if you turn it like this, to the right in order to pass by all the other channels and not to create an oil leakage or a combustion leakage. So the next important things to mount are of course the levers, or the rockers. You can see that the rockers will simply be slid on to the brackets. There won't be any screw to hold them in this place. This will be, or the rockers will be secured only by the bracket on the one side and on the other side by the cylinder head itself. The brackets will be screwed down by the same screws which will screw down the whole head and the cylinders. So I have to use a very long M2 screw which will go through the bracket, through the head, through the cylinder into the engine block. The other mounting holes are a bit easier to reach. There are specific pockets for them. You can see them here. Okay, so the last thing I want to show you concerning the cat model is a section through the whole engine. So here you can see the positioning of the head, the size of the head compared to the cylinder, and you can also see the piston and the positioning of the crankshaft. So now I just move the section a bit more to the rear so I can show you the long M2 screw I was talking about. As you can see, here on the top there's the head of the screw, and it will screw down the brackets, the head, through the cylinder, into the block. Of course, on the other side there will be the same screw, which you can't see now, but in the final model there will be also a second screw, securing each cylinder with 4 screws. Okay, so far this is the latest version of the cylinder head and the camshaft. As you've been able to see, there are still a few cams missing on the shaft for the other 2 cylinders. I still have to figure out some things for the first cylinder. Once I've done that, I can simply copy the design to the remaining 2 cylinders and therefore finish off the camshaft. One more challenge will be the other cam, because I can't simply copy the right side to the left side because of the different timings. But again, if I figured out the way of doing, I can transfer the design or the way of doing to the other side, and it will be a lot easier than for this side. So for now, I will just give you some time looking at the files. Now that you have taken a look on the CAD files of the cylinder head, I will show you the 3D printed part of it. So as you can see here, this is the 3D printed part. It's printed in resin. Compared to my hand, it isn't that large, isn't it? We have some cooling ribs on the side. This is the back side where the second ball bearing should sit. This is the front side where the first ball bearing will sit. This is the oil feeding line in here, and this is a mounting hole for the cover of the belt. So there you can see the larger holes are for the glow plugs, and there inside you can see the little oil feeding lines. Yeah. To be honest, I'm quite happy how this 3D print turned out. Yeah, looks quite fine to me, I would say. It's one of the first parts I ever printed, by the way. So very nice. One detail I very like about it, I hope the camera can show it. You can see the threads maybe in here. Yeah, a little bit, you can see it. So I try now getting the glow plugs, which I will use here, and see if I can fit them through those tiny holes here. So hello again from my future me. I hope you enjoyed the video, and leave a comment in the comment section below. And join me in the next episode when I will show you the simulation of the rockers and the camshaft. So thanks for watching and see you soon. Bye!